For much of human history, we had no way of dealing with the threat of asteroids. While we were capable of observing them, tracking their movements, and even calculating when and where they might collide with Earth, we had no means of changing their trajectory or preventing a catastrophic impact. This was especially concerning, given the potential for massive destruction that an asteroid impact could cause. Despite knowing about the possibility of asteroid collisions, humanity's ability to respond was limited to merely predicting potential impacts. However, in a groundbreaking moment for both space exploration and planetary defense, scientists at NASA developed a viable mechanism to protect Earth from asteroid impacts, and in 2021, they proved this technology through a live experiment. To understand the significance of this achievement, let's look at a major event from the past. Around 65 million years ago, an asteroid the size of Mount Everest, about 10 kilometers wide, collided with Earth. This impact changed the course of the planet's history. The aftermath of this collision was catastrophic, resulting in the extinction of the dinosaurs and a major shift in Earth's environment. The explosion released enough energy to cause massive wildfires, tsunamis, and a climate change that drastically altered ecosystems. While the consequences of that impact were devastating, the event also serves as a reminder of how vulnerable Earth is to objects from space. Despite the enormous scale of the impact and the extinction it caused, humanity didn't have the technology to prevent such disasters, until now. Fast forward to the present day, and we are no longer powerless in the face of asteroid threats. Advances in technology have made it possible to track and monitor asteroids with much greater accuracy. NASA, for example, has an extensive catalog of near-Earth objects, NEOs, which includes over 26,000 asteroids that will pass near Earth in the future. These objects vary in size, with 16,420 being smaller than 100 meters, 8,007 being about 1 kilometer in diameter, and 888 being larger than 1 kilometer. While none of these asteroids are currently on a collision course with Earth, the fact that we can predict their paths means that we have the potential to intervene if one were to change its trajectory. The possibility of a large asteroid colliding with Earth is still a very real threat. Even a small asteroid, let's say 1 kilometer in diameter, could release enough energy on impact to match the destructive force of 1,000 nuclear bombs. The consequences of such an event would be catastrophic, likely leading to widespread devastation, changing weather patterns, and possibly the extinction of many life forms, just as it did for the dinosaurs. This potential for destruction, however, no longer has to be a certainty. NASA, in collaboration with other space organizations, has developed new technology to change the course of an asteroid before it can strike Earth. The technology behind this new planetary defense system is called the kinetic impactor technique. In essence, this approach involves sending a spacecraft to collide with an asteroid at a high speed in order to alter its trajectory. The idea is that even a small change in the asteroid's direction over time, thanks to its vast distance from Earth, could prevent it from colliding with our planet. While this might sound like something out of a science fiction movie, NASA's scientists have proven that it's not only possible, but it's already been tested successfully. One of the key challenges in space is the lack of friction. In space, objects continue moving in a straight line at a constant speed unless acted upon by an external force. This means that an asteroid moving through space will continue on its current path indefinitely, unless something alters its course. The absence of air resistance and gravity in space allows asteroids to travel for millions of years without encountering significant obstacles. However, if such an object comes too close to Earth, our planet's gravity can draw it in, potentially altering its path and causing a catastrophic collision. To deal with this threat, NASA proposed the idea of using a spacecraft to collide with an asteroid while it's still in space, well before it can enter Earth's atmosphere. The collision would not be destructive enough to break the asteroid into pieces but would instead cause a slight shift in its trajectory. The spacecraft would be designed to travel at a very high speed, close to 23,000 kilometers per hour, and strike the asteroid at a precise angle. This would be enough to change the asteroid's path, sending it off course and preventing a collision with Earth. In 2021, NASA launched the Double Asteroid Redirection Test, DART, mission to test this theory. DART, which cost $325 million, was sent into space aboard a SpaceX Falcon 9 rocket from Vandenberg Space Force Base in California. The spacecraft was equipped with cameras, thrusters, and a radio system to send real-time images back to Earth as it approached its target asteroid, Dimorphos. Dimorphos is a small asteroid, just 170 meters in size, and it orbits a larger asteroid called Didymos. While Dimorphos may seem small in comparison to Earth, it was considered the perfect candidate for this experiment. Despite the DART spacecraft being much smaller than Dimorphos, scientists at NASA calculated that if DART were to strike the asteroid at a speed of 23,000 kilometers per hour, it would be able to shift Dimorphos's trajectory by a measurable amount, around 1%. Over time, this small change in direction could prevent Dimorphos from colliding with Earth, effectively neutralizing the threat. After months of travel, DART reached its target on September 26, 2022. The spacecraft collided with Dimorphos at high speed, and the entire event was broadcast live, with the spacecraft's cameras capturing the dramatic final moments of the collision. The results of the mission were historic. This marked the first time that a planetary defense system had been successfully tested. Experts believe that, as a result of the collision, Dimorphos shifted to a new orbit, just as the calculations predicted. However, the full results of the mission will only be known after a few weeks of additional observation. This success has opened the door for more advanced planetary defense measures in the future, allowing us to potentially protect Earth from larger asteroids as well. While the DART mission focused on a small asteroid, the real question is whether this technology could work on a much larger object. What if an asteroid the size of the one that caused the extinction of the dinosaurs, about 10 kilometers wide, were heading toward Earth? Would the kinetic impactor technique be enough to change its course? The answer is still uncertain, and scientists are continuing to study the results of DART to understand the full potential of this technology. However, the fact that the method has been successfully demonstrated on a smaller asteroid gives hope that we may be able to defend Earth from even larger threats in the future. In conclusion, the success of NASA's DART mission marks a major step forward in the field of planetary defense. While we still have much to learn, the possibility that we can now alter the path of an asteroid is a monumental achievement. This technology could one day help protect our planet from the potentially devastating consequences of an asteroid impact, giving us a new tool in our ongoing effort to safeguard Earth. As we continue to monitor the results of the DART mission and improve our understanding of planetary defense, we may be able to prevent future asteroid impacts from threatening life on Earth. What are your thoughts on this new technology? Do you believe we can defend against a large asteroid impact? Or is it still a challenge that lies ahead? Share your thoughts.